Today, we're going to be looking at topics 3.1 to 3.3, which covers periodic phenomena and the unit circle. So, the first topic is going to be focusing just on what periodic graphs are, and then the second is going to focus on sine, cosine, tangent, and like the significance of these, and which you may have learned in geometry, but then like going deeper on them. And then also values of functions on the unit circle, and we're going to look at what the unit circle is as well. Okay, first thing we're going to look at periodic phenomena. So, if you look at a lot of graphs, if you look like a quadratic graph, let's say just y equals x squared, right? That's the parent like quadratic graph, simple graph, right? Just goes something like this. It's interesting. Like if you can see that it's like it forms like that U shape, but it's not like repeating and repeating and repeating. It's like if you take a point that's like -5. That point's going to be different from a point that's like, let's say, -2. That's going to be that. And here, it's like 1. That's a different point. And like, of course, like, for example, if you go 2, then it's the same point as -2. But like, it's not a periodic function. So I'll show you what a periodic function means. A periodic function is something that just keeps on repeating. So if you look at this graph, right, it's going, let's say this is 0, 1, and -1. Or actually, they've given us like an amplitude and midline, so I'll use those points. 3, 5, and 1. Okay, so first it starts at the midline of 3, then it goes up, it forms, this all almost looks like a quadratic, right? It's going up and then coming back down, and then going down, coming back up. And it's like, it's just repeating, and it repeats this infinitely, right? And this point right here, I'm going to have that point be 2 pi, this point be 4 pi. So if you look at this graph, looking at the pattern, the period is 2 pi. So what's that mean? That means every interval of 2 pi, the graphs are going to look identical. So like if you look from this point to this point, right? 0 to 2 pi, because this is 0, 0. 0 to 2 pi, it's going to look identical to 2 pi to 4 pi, and that's going to look identical to, for example, like 2000 pi to 2002 pi, because it's a periodic function. It just repeats. And this way we can find points that are super far away. For example, this point right here, it's at pi, right? And since I know that our period changes in intervals of 2 pi, I know that as we increase by 2 pi, all of those are going to have the same point. So if I asked you, the what is the y value for when x is 3677 pi? Since I know it's an odd pi, has to be 3. Y equals 3. And it just keeps on repeating. So, and here, what it says here, a function is periodic if f of x plus k equals f of x for all x, when k equals the period. So that's saying what we're saying here, right? The period is 2, so f of x, I mean, the period is 2 pi, right? So f of x plus 2 pi equals f of x is what's that saying. So for example, if we have x equals 0, then f of 2 pi, because at 0 plus 2 pi is just 2 pi, right? F of 2 pi equals f of 0, function of 0. Because when x is 2 pi, y equals 3. When x is just pi, I mean just 0, y also equals 3. And then there's characteristics of periodic functions, which is the amplitude. And you can find the amplitude by subtracting the maximum minus the minimum and then dividing by 2. And another way you can just do it is like if you subtract the maximum minus the midline, or just the difference between the midline and the highest point or lowest point, which in this case it's 2, so therefore the amplitude equals 2. The midline is going to be also the max plus the minimum over 2. So here, 5 plus 1 divided by 2 is 3. So it's basically just the average of those maximum and minimum because it's exactly in the middle, right? So that midline is going to be at y equals 3 for this graph. And the period is going to be a length of one complete cycle, which is 2 pi over here. Right, Pranav. You were asking how do we find wait, let me look at what you asked exactly. I was really late. Can you explain how to find the period on graphs? Right, yeah, of course. So to find the period on a graph, let's say you're given a graph like this, right? It's going. The period is gonna be where the graph like is repeating and repeating. For example, so here, that's a little, I said that a little weird. Let me just show you. So let's say that this point right here is going to be 2 pi. This point right here is going to be 4 pi. Now, we can see that from 0 to 2 pi, the graph's making this shape, right? It's going like that, where that's the midline. If you look from 2 pi to 4 pi, that pattern repeats. So to find the period, you're just going to look at where the pattern starts repeating. Like from here, it makes this upside down U, and then it makes a normal U, and then it goes back to the upside down U, right? And that should signal to you, okay, the pattern's starting to repeat, which means my period has ended somewhere there. So like from here to here, if you can see those two lines, that's going to be your period, right? And then, therefore, like this loop just keeps repeating. So any point when you increase it by intervals of the periods, for example, if you increase, like, let's say we have x equals pi over 2, which is this point right here is pi over 2. When we increase by 2 pi, 4 pi, 8 pi, or like 30 pi, as long as it's a multiple of 2 pi, it's going to be the exact same y value. So here, y equals 5 when x equals pi over 2, right? Now, if I add like, let's say 1,000 pi to that, which makes it 2001 pi over 2, x equals 2001 pi over 2. It's easy for me to say it's just y equals 5. And you guys can, not right now, but you guys can like later just go and check out on Desmos and like put in like sine x and the function sine x or cosine x, sine x, and test it out for you guys for yourselves, and you'll see. And so, and here's another good way to do it. The period, like I said, we're looking for the pattern where the pattern ends, the pattern starts. You could also do this by measuring between the peak and the peak. So here there's a peak at pi over 2. Here there's a peak at what would be 5 pi over 2. So the difference between these two peaks is 2 pi. So therefore we found our period. You could also do that with the minimums. This point is 3 pi over 2. This point is 7 pi over 2. The difference between the two is going to be 4 pi over 2, which is also 2 pi. So you can find your periods by the difference between maximums or the difference between the two minimums, or like just looking at the patterns. So there's a couple ways to do that. And then increasing intervals is wherever the function rises. For example, from 3 pi over 2 to 5 pi over 2, it's rising. And then like it's rising, and then it's decreasing from 5 pi over 2 to 7 pi over 2. It's alternating between increasing and decreasing. Okay, now here's an example of a periodic function. A Ferris wheel has a diameter of 30 meters, and its center is 20 meters above the ground. One revolution takes 4 minutes. Okay, so let's try to draw the graph for this. So first of all, the center is 20 meters above the ground. When we're given like a center, that usually indicates to you that that's the midpoint, right? So that's going to be our midpoint. a midline, not midpoint, sorry, midline, which is 20 meters. And it says that it has a diameter of 30 meters. So I want you guys to think about that. If it's a circle, like a Ferris wheel is a circle, right? It has a diameter of 30 meters, then it must have a radius, which I'll show in blue, of 15 meters, which means this goes up 15 and down 15 from 20. So our next 2 points for the amplitude is going to be the radius, which is 15, and our maximum is going to be 35, and our minimum is going to be 5. Do you guys understand why I got those points? And if not, then just let me know. And one revolution takes 4 minutes. So that means our period is going to be 4 minutes, right? So I'm just going to write 4 over there. Then I'm going to have like a couple points. I'll say 2, 1. Usually you want 5 total points. So you're going to, since you have 4 as the maximum point, you divide that by 2, and then you fill in the midpoints, which is like 1 and 3. So let's say it starts at the lowest point, then it would go something like this, 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 and then it would keep repeating. And that's going to be our period. And as you can see, the amplitude is in fact 15, midline is 20, and the period is 4 minutes. And here from a table, we'll look at it. Okay, so first let's try to find our period. Remember, to find our period, we can subtract the 2 maximums or 2 minimums. So I see a maximum at 5, maximum at 5. Okay, so now I can look at the y values for these two, which is going to be 4 and 1. I mean the x values, sorry, not the y values. It's going to be 5 and 1. So 5 minus 1 equals 4, which is the distance between two of the maximums, which tells me that the period equals 4. And notice a mistake that we could have made here. A mistake that some people might accidentally make is see the threes, they're only 2 apart. And you might get, okay, there's a 3 here at 2 comma 3 and then 0 comma 3 and subtract it and get the period is 2. But the reason that's wrong is 3 is going to be our midline. But another way you could have done it is use the minimums, which is at we have one at 3 comma 1 and one at 7 comma 1. And if we do the same process, we'd still get a period of 4. Maximum is 5, minimum is 1. And remember, to get our amplitude, it's halfway between our maximum and minimum. And to do that, we subtract the minimum from the maximum and divide by 2. So maximum minus minimum over 2, and that equals 2. So that's going to be our amplitude. A equals 2. And the midline is going to be uh, halfway between our halfway between our maximum and minimum, which our midline is going to be 3, m equals y equals 3. And I think I worded the amplitude wrong. The amplitude is going to be like the distance between your midline and the maximum slash minimum points. Okay, now I'm going to have 2 questions for you guys to find, to work on. So here I want you to find the amplitude, midline, and period for this first one, and use the details about what from where to where it varies, which gives you the maximum minimums, and then the duration it takes. And then look at this table and then find if the function f is periodic. So look for if it's repeating. And if it is, then find the period. And then next find the amplitude and midline. And then finally, what intervals is f increasing in the first period? So what's that asking for is, let's look back at this graph over here. The first period would just be 0 to 2 pi. So this part after, we'll ignore like this whole part. That's like irrelevant. We're just looking at the first period. Where is it increasing there? And so go ahead and take a shot at these 2 questions and I'll explain it right after, and let me know if you guys have any questions in the meanwhile. All right, I'm gonna go ahead and explain these in three, two, one. Okay. So a pendulum swings so its distance from the center is between -8 centimeters and 8 centimeters. Right away, I can tell the midline is gonna be it's gonna be the halfway point between -8 and 8, right? And right away you can tell that is gonna be y equals 0. And algebraically we solve that by subtracting no, sorry, adding the maximum plus the minimum, which is 8 plus -8, and then dividing by 2, which this is just 0 divided by 2, so y equals 0 for the midline. Now for the amplitude. Uh, for the amplitude, again, if the midline is 0 and the amplitude is distance between the center and the maximum slash minimums, then the amplitude is going to equal 8. And again, algebraically, to solve that, you subtract the the minimum from the maximum. So the maximum is 8 minus the minimum of -8 is going to be 8 minus -8 is the same as 8 plus 8. That's going to be 16, and you have to divide that by 2. So that equals 8. So that's correct. And one full swing takes 2 seconds. So if we're looking at a graph, right, and the swing, let's say the swing starts like high and it drops down low and then it swings back and it goes high, the period would end when the swing restarts. So the duration of the swing is the same as the period. So our period is going to be 2 seconds. 2 sec. Okay, first, is F periodic? Okay, I see the X values are increasing constantly, so they're increasing by 2 consistently. And then the Y values, they're like, it looks like the midline is 4. I mean, we're seeing 4 a lot, we're seeing 7 a lot. It goes from 4, so it would look something like this: 4 to 7 to 4 to 1 to 4 to 7 to 4 to 1. So yeah, this looks like a periodic. So yes, check mark for it's periodic. Now to find the period, we subtract the X values of two of the maximums. So the maximum seems to be 7. So let's look at the two X values for where Y equals 7. We have X equals 2 and X equals 10. So the period must be 10 minus 2, which is 8. P equals 8. Now, amplitude and midline. Maximum, the max is 7, right? And then the min is 1. So the midline has to be halfway between these 2 points, which is going to be 7 plus 1 divided by 2, which is m equals, it's at y equals 4. And the amplitude is going to be the distance between the midline and the maximum slash minimum points. And remember, one way you can quickly do this is if you know the midline, you could just subtract the midline from the maximum. The midline is 4, the maximum is 7. So 7 minus 4 equals 3, which is the amplitude. So A, it's just going to be 3. And remember, the other way you could solve it is the max minus the minimum divided by 2, which is 7 minus 1, which is 6, divided by 2, which also gets you 3. Now, on what intervals is F increasing in the first period? Okay, now it looks like we have to draw it out. Okay, what just happened there? Draw it out. So let's say 4, 7, 1, and 2, 4. Remember, our period is going to be 8, so we have to go to at least 8. We're looking at the first period. Now let's plug in our points. 0, comma 4 from the table. 2, comma 7. 4, comma 4. 6, comma 1. And 8, comma 4. Okay. So it's going like that. And it would just keep repeating, but we only have to look at the intervals where it's increasing in the first period. So I'm going to use a highlighter for this. Clearly, I can tell that it's increasing from here to here. from x equals 0 to x equals 2. And then again, it's decreasing from 2 to 6, and it bounces back and starts increasing from 6 to 8. So the answer for the intervals that's increasing in the first period is going to be 1, no, sorry, 0, comma 2, then union. Union is like a way of saying and, I'm pretty sure you guys know. 6, comma 8. There we go. Now, we're going to look at sine, cosine, and tangent. So, here's how they work. With the standard, this is the unit circle, right? So, if you just look at a circle, say it's an all right circle. Okay. Any point, let's say this is a point we're choosing. If we draw a line to this point, right? And by the way, I'm going to just draw x-axis and y-axis so it's like easy for you guys to see. If we draw a point, then right away we can draw an altitude, which makes this a triangle, right? This is a right angle. And let's say this point, if you think of this angle as, let's name this angle theta. This is theta, by the way. Then, first of all, this is going to be a radius, right? This is going to be sine of theta. And this is going to be cos of theta, specifically when the radius equals 1, r equals 1. And this is the fundamental of all of trigonometry, which will be all of unit 3 of pre-cal. And it's probably going to be one of the harder units of pre-cal, but it's also one of the more interesting ones. So sine theta, cos theta. And do you guys see why that is? Remember that sine of this angle theta is going to be this side divided by the hypotenuse. But if the hypotenuse is just 1, then it's just going to be this side, right? Now, that's what it says here. Cos theta equals x coordinate, sine theta equals the y coordinate, and tan theta equals the sine, uh, equals the y coordinate over the x coordinate, which just equals the slope of the ray equals tan theta. And then quadrant signs, it's saying there, it's like cut out. But okay, I don't think it's too important. So tan is undefined when cos theta equals 0, because if you think about it, it's sine theta over cos theta, right? Over cos theta. Now we know that anything divided by 0 is undefined. So therefore, here, let me erase. Tan theta. And theta is like a way of saying just the angle. It's like x. Tan theta equals sine theta over cos theta. Cos theta cannot equal 0, because if that equals 0, then tan is going to be undefined. So I hope you guys understand why that is. And cos theta equals 0 when the unit circle equals pi over 2 and 3 pi over 2, which are these points. But don't worry too much about the points. You guys will learn them. And I recommend that after this class, once you learn them, like every day before the next class, or like until like for like a week, or until you're able to like proficiently just like write down the entire unit circle, you should practice at least like once a day, just drawing out the unit circle. It takes like 2 minutes, but it's useful. And remembering the unit circle is like vital for everything we're gonna be learning soon, and like all trig identities, which trig identities, you need your unit circle and trig solving as well. So the degree radian, 180 degree to radian, you guys know this from geometry. 180 degrees equals pi. So in a circle, there's 360 degrees, which equals 2 pi. To transfer from degrees to radius, it's going to be pi divided by 180. And transferring from radians to degrees is going to be, which means like pi to like the degrees, is going to be multiplied by 180 divided by pi. Okay, here's an example of converting and finding. Okay, converting 150 degrees to radians. So first we have to do 150 pi divided by 180. 150 times pi divided by 180, which 150 over 180 simplified is all 5 over 6. And that times pi equals 5 pi over 6. And on the unit circle, for 5 pi over 6, cos theta of 5 pi over 6 equals negative root 3 over 2. And sine theta equals 1/2. Now, I want you guys to think about y here. 5 pi over 6 in radians, that's 150 degrees, right? So let's look at that on the circle. It's going to be like there. If you draw the triangle, if that's 150 degrees and this plus this has to add up to 180 degrees, this is going to be 30 degrees, which means this is going to be 90, it's going to be 60. Which means if you know your 30, 60, 90 triangles, the 30 side, if the hypotenuse is 1, then the sine is going to be 1/2 because the 30-degree side is going to be half of it. And the cos is going to be root 3 over 2, right? Because it's root 3 times this side, root 3 over 2. But since it's on the negative side of cos, if everything on this side over here is going to be positive cosine. Okay, yeah, sorry, cut out over there. So like I was saying, everything on this side is going to be positive cosine because it's ahead of the y-axis, if you can see. Everything on this side is going to be negative cosine. In the same way, everything over here is going to be positive sine, while below the x-axis is going to be negative sine. So this is going to be negative root 3 over 2. So that way you can learn some key angles for the unit circle, which we're going to look at in a second. But first, again, let's continue with this coterminal angle for negative pi over 4. So what's a coterminal angle? Okay, wrong drawing thing there. Negative pi over 4 is basically from here. Normally, when you go clockwise, you're going this way, right? But when you put a negative, you're going the opposite side. So instead of going that way by pi over 4, you go over here by pi over 4, negative pi over 4. And to find the coterminal angle, which means what's another angle that gets us to the same point over here, which is negative pi over 4? You'd have to add 2 pi. And that would be negative pi over 4 plus 2 pi equals 7 pi over 4. You guys see why that is? Because 7 pi over 4, if we keep following it, then it does the same thing. And we're adding 2 pi because that's the length of the whole unit circle, right? So if we add by 2 pi, then it's going to get us to the same point. Another coterminal angle, if you think about it, is we add by 2 pi again, and we get 15 pi over 4. 15 pi over 4 also works. So there are infinite coterminal angles when you really think about it. And then this, again, we'll ignore until we get to unit circle. And now we have 2 problems for you guys. For each, state which quadrant or axis the angle lies it, and the signs of sine, cosine, and tan. So before that, I'm going to give you some help. Remember, sine and cosine is simple. It's just uh, sine is going to be ahead of the y-axis. It's going to be positive. So sine is going to be plus, plus, minus, minus. And then cosine is going to be plus, plus, minus, minus. And then tan, if you think about it, it's going to be sine over cosine. So I'm going to have you guys figure tan out because if I'm gonna write sine on top of cosine here, right? So plus plus minus minus, that's gonna be your sine. And for cosine, it's gonna be minus minus plus plus for cosine. And with this, you can also find your tan, the tan, because tan is sine over cosine. Here, we're converting to radians, so remember, multiply by pi over 180 and simplify. And here, if sine theta equals negative 3 over 5, find cos theta and tan theta. And your hint for this is the Pythagorean identity, which you have to draw out a triangle. So I'm going to help you guys out on this one as well. This is a little more ahead of units, really, if you think about it. So here, right angle, because then -3, right? Okay, wait, also I draw that wrong. So if we have a circle and it's in the third quadrant, then the point's like there, right? And then draw down, and then the hypotenuse is going to be 5. This is going to be -3. Now you can find what this side is using the Pythagorean theorem, and you can also find cos theta, which is just uh here, let me try theta as well. Cos theta, which is just x, I'm going to label it as x for now, x over 5, and then tan theta, which is -3 over x. So I'm going to give you guys 2 to 3 minutes to solve these two questions, and then we'll move on to the final topic of the day. All right. So for question one, I mean part A, it's gonna be 45 times pi over 180. Now we're dividing by 180 and 45, so we can simplify that by making 45 just one, and 180 is going to become 4 because 180 divided by 45 is 4. So this equals pi over 4. And then it asks the sine, cosine, and tangent signs for this. So pi over 4 is going to be quadrant 1. So Q1. So, okay, you know what? I'm going to write the answers here so I have more space. So it's going to be pi over 4, Q1, and then sine, cosine, tan. For quadrant 1, it's going to be plus for sine, plus for cosine, and positive divided by positive gives you the tan, which is also positive. So that. All right. Next we have B, 270. So 270 times pi over 180. Now we can simplify this by dividing by 90. So this becomes 3. This becomes 2. So it's going to be 3 pi over 2, which lies between quadrants 3 and 4. It's right here specifically. So Q3/4. And then the sign for this is going to be negative, be -1 specifically. The cosine for this is going to be 0. So I'm just going to write 0 because it can't be positive or negative. And the tan is going to be undefined because the cosine is 0. So that's how you write undefined. And for the last one, 330 times pi over 180. I'll just do it in my head real quick so to save some time. It's going to be 11 pi over 6, which is going to be like over here. So fourth quadrant. This is Q4. And sine is going to be negative. Cosine is going to be positive. And negative divided by positive is negative. So tan is also going to be negative. Okay. Here, sine theta equals -3 over 5. So we're going to be looking at a triangle like this, right? 5, -3. You know from the Pythagorean theorem that this side is going to have to be 4. So therefore, and this is going to be theta, right? So cos theta is going to be -3 over 5 because it's the opposite. I mean, sorry. It's going to be 4 over 5 because it's the adjacent over the hypotenuse. Then tan theta is going to be -3 over 4 because it's the opposite over the adjacent side. Finally, sine and cosine function values. So this is going to be what's actually the unit circle. And the thing with this is I can teach it and I can teach the concept behind it, but it's up to you guys to actually like learn and memorize it, which I would recommend doing through either YouTube or just like looking at the picture and drawing it multiple times, like I mentioned earlier. It's really like the core of all of trigonometry. You need to know it. Like I usually like don't tell you guys to like do too much like outside of class, but like just 2 minutes a day, draw the entire unit circle, and it'll help you remember the values for like later when you're really gonna need them. So here are the five key angles in the first quadrant. 0, pi over 6, which is 30 degrees, or they have them written right here, right? 0, pi over 6, which is 30 degrees, pi over 4, which is 45 degrees, pi over 3, which is 60 degrees, pi over 2, which is 90 degrees. Now, the way we get these are 30, 60, 90. We get those through the 30, 60, 90 triangle. So if we have 30 degrees, 60 degrees, and on the unit circle, it goes something like this, right? Then we know that and we know the hypotenuse is 1, right? And the 30-degree side has to be 1/2 of the hypotenuse. And then the 60-degree side has to be root 3 times whatever is the 30-degree side, which is going to be root 3 over 2. So from this, alternating between sine and cosine between 30 and 60 degrees, we can see that sine of 30 degrees equals 1/2. Sine of 60 degrees, in this case, 60 degrees would be the theta, right? So cosine of 60 degrees would be 1/2. And sine of 60 degrees would be root 3 over 2. And then we can also look at the 45, 45, 90 triangle, look at the 45 degrees, 45, 45. Now, if the hypotenuse is 1, we know that the sides normally in a 45, 45, 90, it's x, x, and x root 2. So legs, when this is 1, is going to be divided by root 2. So it's going to be 1 over root 2, 1 over root 2, which the sine and cosine are always going to be equivalent for the 45 degrees. But one caveat to that is the multiples of 45 degrees. Let's say if you go to 135 degrees, which is a multiple of 45 degrees, it's still going to be 1 over root 2 and 1 over root 2, except cosine is going to be negative because it's on that side of the axis. It would be like if we continued the circle, be somewhere like here. So cosine would be negative root 2 over 2. Or I said negative root 2 over 2 because although this is 1 over root 2, we know that if we rationalize, we multiply our root 2 on top and bottom, then you get root 2 over 2. So therefore, your special angles are going to be pi over 4, pi over 6, pi over 3, pi over 2. And then the key Pythagorean identity to like for all of this is going to be sine squared of theta plus cos squared of theta equals 1. And we'll prove that in topics like 3.4 and later. But for now, just remember that cos of negative theta equals cos of theta, sine of negative theta equals negative sine of theta, which means it's the odd function. And here is the complete unit circle. It's a little blurred out. So I'd recommend just like look a picture up or get a video, but I won't teach you guys the whole unit circle right now. It's not possible for me to do in these next couple minutes that we have. But like I said, you guys should definitely go and check it out after. Here with the find the exact values for theta equals 5 pi over 6. So that's 30 degrees, right? And so then you can make a triangle. So in this circle, 30 degrees like somewhere over here, right? So it makes a triangle like that. This becomes 30, 90, 60. And this is for the unit circle. So again, it would be 1/2 root 3 over 2. So because of that, but this, sorry, this doesn't equal 30 degrees. This equals 150 degrees. But we can use the reference angle method to know that it's 30 degrees. So let me show you that. Reference angle is going to be when you add or subtract 180 degrees, you get the reference angle. So 150 degrees, if you subtract 180, then it's going to be negative 30 degrees, right? Which is just 30 degrees because you have a negative angle. So it's going to be 30, 60, 90. Then if the hypotenuse is 1, this is going to be 1/2. This is going to be negative root 3 over 2 because cos is on the negative side. So cosine of 5 pi over 6 equals negative root 3 over 2. Sine of 5 pi over 6 equals 1/2. A circle has a radius 6, centered at the origin. Find the coordinates at 2 pi over 3. For the coordinates, it's always going to be r, which is radius times cos of theta, comma, r of sine of theta. So cos 2 pi over 3, which is 270 degrees, is going to be 0. Remember, it's at like this point of the circle. So uh, it's going to be 6. No, sorry, that's 3 pi over 2. I confused myself for a second there. 2 pi over 3 is 120 degrees, and cosine of 2 pi over 3 is going to be negative 1/2. So it's going to be 6 times negative 1/2, comma, 6 times root 3 over 2, because sine of 2 pi over 3 equals root 3 over 2. And explaining it, like I said, you're just gonna have to see the unit circle. And this is where like the unit circle comes in. Like you need to know these points. And that's one piece of homework that I would recommend you guys do. Like I can't say it enough. And from this, you get negative 3, comma, 3 root 3. Okay. Here, find the values of sine and cosine. Again, you need to know the unit circle for that. The circle of radius 10 is centered at the origin. Find the coordinates at 5 pi over 4. For 5 pi over 4, so you would find cos of 5 pi over 4 and sine of 5 pi over 4 and multiply both of these by 10. So uh, then you get the coordinates for it. So all these problems, I won't have you guys do them right now. I'm going to post this recording on YouTube. Once you guys learn the unit circle in the next upcoming days, if you want to go and look at the video, which maybe some of you are watching it right now, uh, then attempt these problems only after learning the unit circle. And with that being said, that's going to be it for today. And I'll see you guys next time.